Okay, so I usually ask what the homework was, but it looks like I'm looking at it, right? So homework was just to write, is it just to do the new constructor? All right, so we're supposed to have, so remind me, what does it mean to have two functions or more than one function with the same name but a different number and or type of parameters?
Polymorphism.
Polytheism.
Theism. I'm sorry. I just came out of philosophy class. I'm sorry. I'm so sorry.
Polytheism, that's cultures that believe in like multiple gods, right?
Again, like I said that. I just came out of a philosophy class. Please forgive me.
Yeah, that's like Stargate SG-1. The gold system lords. No, it was a good one. I love that show. That show's so good. Okay, so in this particular case, we have something that looks like a function, looks like a method. It actually kind of isn't, and we're going to talk about that a little bit today. In fact, actually, let me talk about that. Oh, did you find it? Oh, lucky.
Feels good, man.
Yeah, feels good. started your day right.
Yeah, I know.
Let me actually talk about that real quick here, because we do have two functions. These are normal functions, or typically in object-oriented languages, we refer to functions as methods. So you'll often hear me use those interchangeably, just depending on, I guess, my mood or something like that. But these would be synonymous terms, would be, in fact, let me just quickly give you, I think we've had this slide before, but just since I'm talking about it right now, and I tend to like to talk about programming from the perspective of kind of the historical nuances, how things have changed, because really very little has changed, and we just learn the nuances of that new language. Like as an example, in the 470 class this semester, we use a language that the students have never seen before called Scheme. And I spent 20 minutes on the first day of class teaching them the entire language. Memory, asking questions, repetition. And then they immediately get their first assignment. Okay. Now, they still have to deal with the nuance of the language, right? There's, it's a little bit different syntax, kind of structure and stuff of that, but how do I remember crap? How do I ask a question? How do I do repetition in one way or another? And now you know the whole language. So we're going to call this slide what? Functions through the ages. LOL. ... LOL. All right. So KK, thanks. It's like just the weirdest Lippmann slides. He actually went to a website in Greek, copied it, and pasted it in there. He has no idea what it was. He just grabbed something from the middle of the day. I did that the other day in our Bible study at my church, because I used the Bible on my phone. And I could pull up all sorts of languages on there. I can't pronounce most of the languages, but Greek you can kind of sound out reasonably well. So, the pastor's like, okay, is somebody willing to read something chapter 2 verses 10 through 14? I just read it in the Greek. They just thought I was speaking gibberish. A couple people in there were like theology profs from, I go to Beautiful Savior here in Mequon, and a couple of those folks are theology profs, so they probably knew it. And they, could make fun of my poor pronunciation. Speaking of which, let me create a quick slide for this. This is a free food announcement. So Concordia Sunday is this coming Sunday, which is, what's the date for Sunday? Okay. So 9/22/19. So church is from 9 to 10 a.m. And then there is a free brunch from, call it 10 to noon, something like that. There'd be like egg casseroles and all sorts of sides and things like that. So it's free. All you have to do is bring yourself. So officially, I will encourage you to come to church at 9. and I'll be there. But if you are too busy for that or go someplace else or whatever, at the very least, come by for the free food at 10 to noon. It's specifically our Concordia Sunday, so we kind of catered to the Concordia students, and you'll find a lot of your, several of your faculty members might be there. We have several Concordia faculty members who go to that church. So you're all invited. That's this coming Sunday. And it's just go down Port, turn right on Mequon Road, and it's about a mile down on the right. It's right off of Mequon Road. Questions about that free food opportunity? Okay. And of course, the Ann Arbor people are welcome to bus in. In fact, I'll even make the offer that if the Ann Arbor people want to drive up here, I'll pay for their gas. Both ways. Just as a fun experiment, come for free food at Concordia Sunday at my church, and your trip will, you can also sleep in my house if you want. I got a 1,200 square foot basement. You can just sleep down there. It's finished. It's finished. Just don't even mind the cages that I have down there, and the locks are insignificant. Okay? A brand new flooring too, because that was the basement that flooded in June, and it I'm just now finishing the insurance claim in 3 months. So I had like all this electronic stuff down there, and it was carpeted, and 2 different VR setups.
Yeah.
But it'll work out. All right, functions through the ages, LOL, LOL. Okay, so first of all, what is a function? What's a function? You had to give me just a generic definition for, and we're just choosing function as our most generic term for this guy, even though we can use a different term if we wanted to. Go ahead.
A way to create power tool to do more stuff.
Okay, probably if I kind of go inside your brain and figure out what you actually meant, I think you're probably right. So we're going to call this guy a reusable chunk of code that we write once and can call over and over. All right, so as an example, here's a function called display. So we can create 4 million fractions, and each one of those fractions has a function called display. Whenever we need it, we just say f.display or f1.display or f5.display or myfraction.display. Okay, so this is a reusable chunk of code that we write one time, and whenever we need to display a fraction in some sort of nice format, we call the function. All right, so we're all cool on what a function is? All right. That's a 200 concept. So that's what a function is. So if we go way back in time, we would have called, so these are synonyms. Do I know how to spell synonyms? Synonyms for functions. Subroutines. I'll put function here. Procedure, method. Let's see. Yeah, we'll leave it at that. I think those are kind of the famous ones. So subroutines, this is probably the earliest. Let's leave it earliest. All right. Functions and procedures kind of complemented each other. So in its original use, functions returned a value. Procedures did not return a value. All right, so in Java, we have functions that have a return type. This guy has a return type of void, which means he returns nothing. This is our historic procedure. A function that does not return a value would have been called a procedure. Okay, in older languages, well, some older languages, Pascal worked this way. They had something called a function. They had something called a procedure. Okay, so procedures did something but didn't actually spit an answer out. Whereas this guy up here is a function. He returns a value. So he will have a return statement somewhere in there. Okay, so he's going to do some stuff. He might even display some stuff, but ultimately he's going to spit out an answer. Functions historically have returned values. So we'll call this guy the historic function. We'll just say returns a value. Historic procedure does not return a value. Just names. All right. You could just call both of these functions. That's fine. Methods. This last guy here. This is the naming convention that came with object-oriented languages. Covers both functions and procedures. So if we're kind of officially, historically referring to these guys, if we have something that returns a value, we'd call it a function. If it doesn't return a value, we'd call it a procedure. But with the advent of object-oriented languages, we have methods, which just says it is a reusable chunk of code that may or may not return something, because they all return at least void, which is nothingness. Okay? And actually, this is even, let's call it a somewhat truth, because prior to methods, you still had languages like C. C predates object-oriented languages, and it has effectively a single kind. We can call it a method. Most people would call it functions. But if you're an older programmer learning C, you might still just call them subroutines. If you were a Pascal programmer that's learning C, you'd call them procedures sometimes, or functions sometimes, or just flip-flop them, or maybe you have your favorite word, whatever. Doesn't matter what you call them. Just so you may hear me use some of these words interchangeably. So when I first started programming, they start off as, we would call them subroutines. Like the quick basic programming language, you would actually define it with the word sub. S-U-B, creating a subroutine. All right, so nothing I'm going to test you over. This is more for historic reference. If you are reading something online or something like that for, to learn about something, you may see these terms used interchangeably. Okay, and here's like a little bit of the nuance of them that is very likely in any sort of modern documentation not going to be used correctly. In fact, I would probably say you're not going to see procedure used very often anymore. But function and method are very commonly just used interchangeably. Okay. So I was about to explain constructors versus methods, right? So first of all, we look at constructors. Here's two examples of constructors here. Here is two examples of methods here. I'll officially use method for this exact moment. I'll screw it up later, trust me, but these are officially methods. We're dealing with an object-oriented language. Java definitely calls these methods officially. Okay. Now, if we just look at these, we notice two distinct differences. There's one most important difference, and that is that these methods down here have a return value. The syntax for a method is, don't worry about this part for right now. I think I've just said, just make everything public for now. I'll tell you why later, okay, something like that. So forget about that part of it. You could leave it off and it wouldn't break anything. But we have a return type, followed by method name, followed by opening parenthesis, followed by list of parameters. In this case, this guy takes 0 inputs. So parameters are synonymous with inputs, right? What does this guy require you to give it in order for it to do its job? All right. Similarly, this guy down here, his return type is void, which means nothingness. Remember, Java is a strongly typed language, so we need to always specify When we have a variable, what kind of value that variable will hold. When we have a method, what kind of value that method will return. If it's not going to return anything, if we're creating the historic procedure, we would put void in there. I do not intend to return anything. We're letting Java know that so that when it goes through the compiler, it can make sure it sets the stuff up so that it yells at you and says, you're trying to store value from a method that doesn't return anything. Or this method must return a value. So for instance, this guy has advertised he returns a string. If I choose to just not return that string, here, I'll just comment it out for right now. That'll be easiest. We get the error up here. He's going to say, you've advertised that you're going to return a string. This method must return a result of type string. In this particular case, I've done nothing in this method, so it's really a waste of space. But I've done nothing including not return a string. Make sense? But now he returns a string again. Well, he returns something. What does he return? This guy, which is an int concatenated with a string concatenated with an int. Notice a nuance in Java that we didn't have in Python. In Java, as long as there is a string involved, the plus sign is treated as the concatenation operator. Where in Python, both sides needed to be string types. So if you had an int that you wanted to glue onto a string, we had to turn that int into a string using the str function. Remember that guy? Where now we can glue things together here as long as one of the elements, it doesn't even have to start with it, but as long as one of the elements is a string that we're using in conjunction with the plus sign, that plus sign will be treated as the concatenation operator, the glue strings together operator, as opposed to do math, do addition. All right, so if we have advertised a function will return a value, see I already used function again. If we advertise a method will return a value, you have to return a value. Make sense? All right, so does that mean here's a method where I've advertised I'm going to return nothing. Does that mean I can't have a return statement in there? This is somewhat of a trick question. I've said I will return nothing, void. But I ask, can I have a return statement in there? Can I come down here and say return 5? Cannot do that. I can't say return 5. Why? Because this guy returns void. Void methods cannot return a value. So I ask again, can I have a return statement in here? No red squigglies. So now we ask the question, what does the return statement do? And this is compatible with Python. We talked about this last semester. What does this guy do? Makes a method immediately end and potentially returns a value. The main function of the return statement is to kill a method. So if I'm in the middle of a loop somewhere and I decided, oh, I've done enough damage here, I've checked for my value, I've set whatever I needed to set, rather than let this guy loop through another 400 times, my work is done. You can just throw a return in there, method's over. Do not pass go, do not collect $200. Go ahead.
So let's say you had a list that hadn't run through the entire thing, and there's a condition that if it comes across this specific letter,
yeah,
you could have a return in that conditional, and then it would end it early.
Correct. Yep, 100%. Yeah, so the return statement makes a method end. Right there and then. Will not go to any more lines. That method dies. You can potentially couple a return statement with a value. In Python, it was always cool to include a value or not include a value. If we didn't include a value in Python, what did a method return? What was our equivalent of void in Python? You saw it print out sometimes. None, capital N, O-N-E. Yeah, so if you tried to display the result of a function where you didn't actually return a value, you would print out none. Like, this is what I got. I ran the function for you. I printed out what he gave me. He gave me nothingness. There you go. Function still did its thing, right? You know, the function still did whatever operations it was going to do. It might have summed up some numbers or whatever. But if it didn't actually return those values, and you were printing out what that function returned, it returned nothingness. So in Python, you could choose to return a value or choose to not return a value or choose to not even use a return statement. Why is that in Python? Why is that okay in Python, but not okay in Java? In Java, I can't come in here and just choose to return nothing. I can't choose to return an int, because this guy expects me to return a string. Okay? This dude is not a string. Get your act together. You told me to return a string. You better give me a string. All right, so he's going to yell until I kind of wrap that guy as a string. Is okay. Everything's fine. Fire's out. All right, so in Java, we do not have the option. When we build a method, we specify what our intent is with that method. Python, being a loosely typed language, which typically goes hand in hand with interpreted languages, doesn't make us tell that story ahead of time. So we have the full flexibility within a function in Python for us to return something, return nothing, return two different kinds of types, right? I can have a single function return some number if it finds it, or false at the end of it. That's legal in Python. That might make my life a little bit harder someplace else where I'm using the result of that function, but Python allows it. Go ahead.
Wouldn't it be easier for it just to not require a specification of string or integer or character?
Well, it depends what you mean by easier. That's how Python works. So if your perception is it's easier, that Python is easier, then sure. But I would also say that it's easier to be a less organized programmer with Python, because Python doesn't force you into making some of those choices ahead of time. So now you aren't kept onto your logical path. If you're writing a function to sum up some numbers, your intention is to sum up the numbers and ultimately return the value, right? In Python, you can potentially forget to return the value. You might write all the right magic code that goes through your whole list, adds everything up, you stored it all inside of a variable called answer, whatever, and then you never actually return it because you forgot. Job will scream at you. It'll say, look, you told me you were going to return an int. You didn't. Fix it. So maybe that's better. Get what I'm saying? So there's a caveat there. Generally speaking, and this goes back to what we talked about last semester, is a compiled, strongly typed language. Those typically go together. Strongly typed languages are commonly compiled languages. Loosely typed languages are commonly interpreted languages. Compiled languages tend to be faster performing languages. Interpreted languages tend to be slower performing languages. Let's call it 99% of the time, it doesn't matter. Computers are fast. Fast, slow, doesn't matter. It's going to be fast. It's going to be fast enough for almost all tasks. Okay? That's why our video games are made in like C and C++, because those are going to be the fastest of the fast languages, ultimately compiling down to just native code that runs right on the processor, where that video games are not going to be written in Python. Not that simple video games could not be written in Python. And by simple, we're not talking that simple. We're just probably talking not like Battlefield or something like that that has zillions of explosions and 50 real-time players in the same world at the same time, very complexy feeling games. You could write Angry Birds in Python, let's say, and it'd run just fine. I mean, it's no problem. And that's one of the most popular games in history. Okay, so nature of the game will dictate what language is appropriate to drive that that game, and then also what the current technology is. You know, you go roll back. We were talking about Super Mario Brothers at the beginning of class. You know, a long time ago when Super Mario Brothers first came out, and we had these 8-bit processors that weren't overly powerful. That game was written in C. Well, you could write Super Mario Brothers today on a calculator using, you know, we have, you know, probably a run on the side of, there probably actually is a toaster somewhere in the world that has Mario Brothers running on it. That probably exists. Unfortunately, it probably does. Yeah, he's Googling it right now. Google that. Google that. But the point is because our machines have become so much faster than they were back then, something that used to, the right tool for the job was C, let's say, now it could be written in almost anything because our computers can just keep up. We'll just interpret it in real time and look, it's Mario Brothers. You know, you're going to be fine. Okay, that kind of makes sense there. So my personal opinion from a computer science perspective, from a programming perspective, is it's better to, even though we learn this backwards, because that actually kind of goes hand in hand with his question. The ideal way to learn programming is to learn a strongly typed compiled language first, so that you're forced into thinking structurally. You're forced into saying, I am going to add some stuff up. I intend to return an int. I will tell you I'm going to return an int beforehand. And then I will police you when you forget. That's probably the best way of learning it. But to his point, he says, isn't it easier to not be forced to deal with all those extra details? Because when you're first starting to learn to program, you've got enough stuff on your plate. Make sense? So that's where the trade-off is. I've heard many times that the perception is, even just we're hiring a new faculty member over in Ann Arbor for computer science, and she gave her talk, like guest lecture last week, and she even said in her guest lecture that she prefers Python because it's easier. Now, I'm sure if I sat down and talked to her and we really got the nuance of what she was talking about, her opinion is probably a lot deeper than that. But it's easy to say a language that forces you to do less is easy, but only in the context of if you already know what you're doing. Like, oh, I have to type less. Great. But if you don't actually already know what you're doing, a language like Python could be a little bit misleading because you might get some right answers for the wrong reasons. Something like that. All right? So we understand the purpose of return. Purpose of return kills a method. Potentially can return a value. This is redundant, all right? Because at the end of every method, there is a invisible return, let's say. When we hit this closing curly brace, this method ends. We just threw in the extra punch. End early. Done. Go ahead.
Unfortunately, besides a ROM hack, I didn't find Super Mario Brothers being played in the toaster. However, I did find a website that does allow apparently to play Super Mario Brothers on HDMI ML5.
What is the
HTML5?
Oh, in a browser.
Yeah.
Oh yeah, that's been done. That's not impressive.
I know.
Running on a toaster is impressive.
Yeah.
Running on a fridge would be acceptable. You know? That's what I'm saying. Yeah. Now you have these refrigerators that will keep your whole grocery list, and when you start running low on milk, it'll actually order it for you. And you can just pick your delivery day, and your groceries just magically show up because your fridge ordered them. Not sci-fi. This exists. You could buy this fridge today.
By the way, 30 gallons of milk.
You can't on your budget? Yeah. Yeah, I don't know how much that fridge is, but we'll just use a multiplier. I'm guessing about 5 times the cost of like a fridge that keeps things cold. I can't afford that either. I use my friends' fridges.
My milk is stored at this house. My egg is
Or you go the other route as, I just live life on the edge. I don't refrigerate anything. What does not kill you makes you stronger. Yeah. I buy all my milks in half pint increments.
People in like Europe don't refrigerate eggs.
Huh?
People in Europe don't refrigerate eggs. They just like leave them on the counter in a bowl.
Or butter.
Yeah.
Well, you don't have a fridge. You already covered that. You couldn't refrigerate butter if you wanted to.
Bags. Have you ever seen that?
Yeah, when I looked at milk trays.
The topics we get into. All right. Okay, so we get the return statement, drill it into your brain. That's a truth across programming. Pick your language, return kills a function. It's not a Java thing, it's an everything thing. Everything thing, is that a thing? Thing? LOL thing. ... LOL. All right, so when we look at methods in Java, we see a distinct pattern in methods in that they all specify a return type. You will see that same thing in C. You will see that same thing in C++. You'll see that same thing in C#. You'll see that same thing in Objective-C, in Swift. Let's just basically say you'll see that under all compiled, strongly typed languages. Methods, functions, whatever's in compiled, strongly typed languages will always have a return type for their methods, functions, subroutines, whatever you want to call them. Okay? Now, if we go to an older language, and actually let me talk about that here in a second, but one kind of truth about Java, and this would be a truth, we can replace Java with probably C#, with Swift, any of our much newer languages. Truth about newer languages like Java. And Java's not that new. Java's mid-90s. Okay, so we're not talking about, just came out last week. In fact, the more modern the languages get, the worse this gets. I probably made it last semester, but I'll make the joke here in a second. Okay, truth about newer languages. They tend to minimize, or tend to attempt to minimize the amount of extra syntax the programmer must write. Sometimes the code is always the same. So rather than making you write those 9 characters, the identical 9 characters, every single time you do the same thing, they simplify the syntax so that those characters are just assumed to be there. Something like that. Okay, I usually refer to this as syntactic sugar. The syntax is there. It's an underlying hidden type thing, but the language itself didn't actually make you be redundant and write something that always looks that way. All right. I'm actually going to give you an important example of that here in a few minutes that kind of shows the history of these languages. And it would be an argument of why I actually think the first language you should learn is like a language like C, or actually Objective-C is a really good first language, except that it's probably the most intimidating of our, call them modern languages, but it really shows something. And I'm going to show you an Objective-C example here in a minute. Okay, so that's a truth about modern languages, is they really try to take things from the previous language that they were based off of, and we've already kind of seen that chart. We got C, C++, yada, yada, yada. And they say, okay, well, what was good about the previous language? They keep all that stuff. And they say, you know what? What could we improve upon the previous language? And one of the things that language makers tend to do is they look at the previous language and they try to find inefficiencies, not just in performance, but also in what you have to type. All right? So an example of that would be with, let's call it constructors, but let's use constructors, let's even look from Python to Java. So I'm going to go over here to my driver class. If I was writing this guy in Python, I would say F1 is equal to fraction 1, 2. These two lines are the same line between those two languages, right? And we might say that in Python, this right here is equivalent to this. If I were to print out F1 here in Python, what would I get? So if I were to put the Python line print F1, what would output? Well, you tell me. You could start off by telling me why your first answer was wrong. Then you can tell me why your second one is right.
It's wrong because it's referring firstly to a memory address.
Can't use memory address to define why your memory address answer is right. This guy is a pointer to where this dude was actually built. This is my call to the Python, presumably the Python constructor called fraction, just like this is my call to the Java constructor called fraction. Okay? So this variable here holds the value that came out of this, and the value is the memory address where something was built. Java makes this pretty clear because it has that new keyword here where we've specified that, oh, new keyword means real estate agent means go get me memory. Right? But Python said, look, if I know we're building the same objects here, but out here I'll build another kind of object. I'll say random r is equal to new random. And it's going to want me to import something, java.util.random, but don't worry about that for right now. All right, so I'm building an object of type random. I'm naming it r. It's equal to a memory address. I'm building an object of type fraction. I'm naming it f4. It's equal to a memory address. Notice the way we build these fractions is always the same. We always put the new keyword there, unless it's a string. And then we can optionally put the new keyword there. But we talked about the string thing, that's syntactic sugar for making strings easier to work with, but they're not necessarily functionally identical. That's the difference between storing stuff in literal space versus, hey, I want new memory for this string. I want fresh French fries, right? All right. So we could say that if we're writing the next language that's basing itself off of Java, that if we always define functions, if prior to the constructor, every single time when we're building an object rather, if prior to the constructor we always have the new keyword, could that be something that we can actually omit and just assume is there? Yeah, if it's always there, why force the programmer to type those 3 characters? Is that a reasonable improvement? Sure. Swift does that. C# doesn't. C# came out close enough to Java where, you still want to feel like a programmer. You don't want to, start taking too much away, all of a sudden you don't really feel like a coder, right? So C# still has the new keyword in there, but Swift, which is the newest language of all of these kind of like modern languages, the Apple language, they have taken away the new keyword, or at least removed it from the required syntax for creating objects. The new keyword actually does still exist for some other things, but not for that. Okay? We might say that's reasonable, that's an improvement. Okay? Now, is this the end of the world, having to put the new keyword here? From a got to cut weight. Yeah, for those of you who are, the inside joke there is we had the conversation at lunch the other day about he's a mixed martial arts guy and doesn't want to fight up in the weight class where he belongs. So instead, loses a bunch of weight before a tournament so he can beat up on smaller people.
Yeah, that's basically.
Okay, so I just assessed that's how it works.
Yeah.
Because I guess if you're like a 150-pound person weighing in at 130 pounds, you still technically are a stronger person. It's just how God built you. So it's like fat cheating.
Well, I mean,
So I told them cool kids would fight up.
Here's the thing. So I did a powerlifting meet, and I was in the 220 to 240 weight class, and I was a little bit heavier, but I didn't want to go to the next weight class because then I'd be at the very bottom of it, and I probably wouldn't perform as well because those guys could push like it's like 240.
Or you'd be extra impressive if you're beating the bigger guys.
Could be, but I probably wouldn't because those guys can push 300 pounds plus, and well, versus me being scrappy 240, I don't think I'd compete. So sometimes it's like it really depends, I guess, on how you interpret it.
Oh, I agree. You're a coward. So that's what I heard. Is that?
I mean,
I can respect the argument
right.
of operating within your appropriate weight class and saying, I want to test myself against folks that are similar build within a certain weight thing.
Right.
But to lose weight to beat up on the smaller people?
It's all water weight.
It's just making excuses for it. Just making excuses for it. But wouldn't it be impressive if like somebody like in boxing or something was like a featherweight guy and just fought up in heavyweight? I mean, we would assume they would just get pummeled. But some of those guys are pretty fast. But the question is, are they going to be able to do enough damage to like the big guys where they land one hit, things are going to get bad quick. But yeah, so I respect you sticking to your weight class. I don't respect you for beating up little people.
Ouch.
It's garbage. So we were giving him a hard time about, like he was like eating really light because I need to cut weight to, so that I pass the test to beat up on the smaller people.
Yeah.
This is just garbage.
First place.
Well, and the thing is, so he's a skilled martial artist, right? So, and you said your normal weight's like 150 something, right?
155.
Okay, I'm 380 pounds, and I'm sure he could beat me up. I don't know what I'm doing. I'm like a soft computer scientist. He's gonna hit me in all the right places. I'm just gonna drop. So, so you can do it, is what I'm saying. I mean, if I had all the ninja skills, maybe it'd be tougher, but just saying. Man up. Is that soundboard?
If you put it like that, I mean, but you don't do mixed martial arts. Imagine someone who was like 250 or plus doing mixed martial arts against him.
No, and I get that. That's why it's appropriate to be in your correct weight class.
Here's what happens too. Like 90% of my game is illegal in my skill level. Because
I'm not just bigger playing a skinny guy, I also cheat.
No.
Okay.
So what I do is I voluntarily go up in a skill level so I can use the stuff that I like to use.
Okay.
But then I go down in a weight class. So it kind of balances out.
What?
Because I go against people that are more skilled than me.
No, back up. What?
But
Well, what he's trying to defend his choice by saying he goes against people that have more ninja skills or are allowed to use more ninja skills. Yeah. Everybody who does martial arts is a ninja to me. All right. So and because they have more ninja skills, you have to fight against the weaker ones to counteract the higher ninja skills.
yes.
But wouldn't it be more impressive if you fought in the correct weight class and really stretched to get those extra good ninja skills to compete against the people that were your size?
It's not extra good.
The answer is yes.
Ouch. Just flat out sad.
Now, in his defense, I follow quite a few sports and I played sports historically. I know everybody does it. That's the problem. And that is the problem, is that if he doesn't do it, then he's going to end up fighting against the guy who is in the 190 or whatever weight class who's cut weight to go against him. That doesn't make it right, but it makes it almost a necessity, is what would maybe argue. That would be your more logical argument.
Yes.
Not because you want to beat up on the lighter people, but because if you don't, a bigger person is going to beat up on you.
I'm going to be the lighter person that gets beat up.
Yeah, no, I get it. It's garbage. People cheat.
It is weird how it works because like I did the water cutting thing where you like kind of just like sweat out a bunch of crap that you don't really need, and I lost like 10 pounds.
I don't need that.
Oh no, you need it.
You do need it, but to like
the way I do it, you need it.
Like I had to get under 220, and I was weighing in at like 226. So I got to 218. As soon as weigh-ins were ended, I started eating like Gatorade and whatever, and I was back to 228. So technically, I was performing above my weight class, but for weigh-ins, I had to be underneath. So it's technically
Everybody
cheating,
does it.
but I didn't know about it.
I have the final solution, and we'll go back to this. Final solution is this. God made each of us the way we are. Single weight class. It's called human. You get into the ring and you go.
I do that too. It's called the absolute division.
Yeah.
Where it's any
Just
skill
like
level, any
Diablo
weight class.
3 or whatever the what is the hardcore thing where if you die you're gone.
Because, like,
But
You don't get a reset.
Because, like, that's what you said. Like, if you are a smaller guy and you end up being like this huge guy, that'd be way more impressive. And that's actually probably a lot more entertaining than.
Yeah, so that comes down to vocation.
Yeah.
You know, if you're 115 pounds deciding to be a ninja, and a lot of these other guys, let's call it I mean, there's going to be a point where you're just like too fat to be effective, right? So let's just say maybe 230 or something is maybe like this. If 230 and ripped is maybe a pretty ideal ninjaing weight or something. So if you're 115, maybe God just didn't have that in the cards for you. You should go do something else, like drive race cars or something, because when you're lighter, the better. Okay, so the human class I'm okay splitting on gender. I mean, I think that's reasonable.
Just
Yeah.
that was different.
Yeah, but builds, look, if you just don't have the right build to be a ninja, LOL, then you should go do something else. That's what I think. That's why I'm not a cross country. I do downhill distance sprinting.
I like that.
Yeah. Once you get me on a slope, momentum takes over from there. All right. Back to constructors.
Back to program.
No, we got to get back to constructors. You got 3 seconds. Go ahead.
Downhill driving, you know.
What in the world are you talking about now?
That's why I'm great on water slides. If you like to go fast on water slides, you want to be on the double person tube.
Oh, yeah.
I had a former student one time at a water park, and he was on the front of the tube, and I was on the back, and we can just go fast, right? And we came out of the other end of the slide, and he hit the bottom but landed on his feet, and I just cut through him like a knife through hot butter. Man, he cried for an hour. It was hilarious. It was. Oh no! He just got crushed. He was just basically we hit. He just stood up and stopped.
Oh,
He just locked in place as I just
That's bad.
train on the tracks. yeah, I agree. It was awesome. All right, so, all right, shut up. Back to constructors. So, shut up.
Shoot.
He doesn't even realize I just stared at him. All right, so we've decided that it's not a completely unreasonable thing for us to cut the new keyword. Seems to be okay, right? But it's also not the end of the world if we stick to, you got to type 3 characters. That reminds us as programmers that, hey, memory is being created. That's not a bad thing to be reminded of, that we're creating some memory. Okay? Now, a language like Swift, let's just use that as our example of our newest strongly typed compiled language. It takes things too far, in my opinion. Swift allows you to, I can't recreate it on here because the editor doesn't allow me to do it. But Swift will allow me to create a fraction. I wonder if the thing will let me do, can I do a tennis ball here? No, it doesn't let me do it. It will allow me to name variables with emojis.
I think that's useful.
It's not. Okay? If you're ever programming in a language, I would start off by saying if you're programming in a language that allows you to use emojis,
Try again.
be suspicious. I write a lot of stuff in Swift because I do a lot of iOS development, and that's the current. If you're writing a new software product in iOS, you're going to use Swift. Older, it was Objective-C, and then you have some translation between the two. But Swift is the cool kid to do it now. But if you're using a language that allows you to use emojis, and you use emojis, you're not a programmer. I don't know what you are, but you're something else. Okay, that's the coding equivalent of cutting weight.
What?
And we just connected the loop. That's why it was class appropriate.
Yeah.
Right there. It was all part of my example. All right. Just bad form. Okay. So we kind of get where there's some level in there, but we're still at the mercy of whoever came out with the languages or something like that. But what's important for us from a programmer perspective is we do need to understand that sometimes there are things that are actually there that we don't see, okay? Or as if they were actually there. That maybe in an older language we would have always written, but in a newer language we didn't. So, for example, let me just cut out a couple of these broken things so I don't forget. If we look at a Java constructor here, like this guy, he has no return type. Why? Because his return type is always, 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 always going to be a memory address. Java doesn't have a syntax for us to define to work with memory addresses, so that's a good thing that they don't require us to put one in there. We've seen that memory addresses do exist in Java. We just don't have a special syntax for doing it. If we were working in a language like C++, we might return something like a void pointer. That might be the return type of our constructor in C++. You know, we will return a generic memory address. All right? Would be reasonable. That we don't have a special syntax for dealing with addresses and values at addresses in Java. Java instead just decides that, hey, look, when you pass an object around, we're going to pass it by address. It's lighter. When you go to try to use an object, we're pretty sure you have no use for the memory address of that object. Instead, you want to access the object itself. So we'll go ahead and follow that pointer for you, give you direct access to the object, do what you need to do. All right, so Java kind of makes those decisions for you. And it's not unfair to say that 99+% of the time, Java makes the right choice. And if you learned from Java and that's all you've ever developed in, you probably feel it's 100% of the time that Java makes the right choice because you haven't known any different. Now, if you grew up as a C or a C++ programmer and you got very, very skilled at programming and you maybe learned a couple of weird hacky tricks or something, every now and then you might be solving a very strange problem where having direct control over memory might allow you to add a little efficiency or something like that. So in that very rare, possibly will never happen for most developers, probably will never happen for most developers situation, you might wish you had direct control over memory in Java. But for most of us, Java taking care of some of that decision making for us is better than us having to type extra things and possibly making some poor choices. If you think back to last semester, we used that example of, let's say you're having a party at your house. Do you hand me your house and tell me to open the door at 8 p.m. or do you give me the address where your house is? You give me the address because houses are heavy. Remember that example from last semester? Okay. Well, a language like C and C++, well, if we're dealing with objects, a language like C++ would allow you to hand somebody the house if you wanted to. We can say that it never makes sense to hand somebody the house, but maybe in some weird alternate dimension, in some very, very, very specific circumstance, maybe it would. C++ would let you accomplish that. Java would not. All right, so we'll call a lot of those decisions reasonable decisions from Java. They omitted things, so Java said, hey, look, when we call this constructor, it will always, always be preceded by the new keyword. New keyword says, get me new memory. That means that the constructor always, always, always will ultimately spit out a memory address. So why should I have to define a return type if the return type is always a memory address? Make sense? All right. So having said that, that's why constructors versus methods in Java have a slightly different syntax. We talked last time about the members of a class being fields, constructors, methods. And really, constructors and methods are really closely related. The exception is constructors do not have a return type And they always, in Java, they always match the name of the class. That's true in Java, that's true in C#, that's true in C++. I think it's true in C++. It's true in several other languages too, but let's just leave it at that. It's definitely true in Java. Okay. Other languages like Swift, typically you could name the constructor in Swift is just init, similar to Python. Constructor in Objective-C, you can make it whatever you want. All right. Now, remind me, what does the keyword this do? What is that guy?
Refers to itself.
It's how an object refers to itself from within itself, right? And this is Java's version of this is equal to Python's version of what?
And then self.
Self. Right. Same way I do is like I use the button to push the slide one slide forward, and so synonyms, right? Self, this, whatever. Where did the this keyword come from? Did I define a variable in here named this anywhere?
No.
But I'm using this variable as if it came from somewhere,
Yeah.
right? Let me just show you. I'm gonna just for time, because we only need. Was the assignment hard? I think we can do it in 3 minutes. It's fine. I just might have to turbo it a little bit. So I'm just going to do Objective-C constructor. Because you're going to see in Objective-C, we actually set the self value, and then we return it at the end of the constructor. All right, so right off the bat, you start seeing with Objective-C, it's using a little bit different syntax. It's using what's called a message passing syntax. So typically programmers get a little intimidated when they start seeing the square brackets and like, oh, this is weird, I'm terrified. Once you get into it though, it's the same crap as any other language. Give me a constructor real quick. Big money, okay, good. Here's a constructor. Notice the name, I said you can name it anything you want. Init with name, room number, constructor. So Objective-C tends to be very verbose. It almost reads like a sentence. Give me a init one of these guys with a name equal to this, a room number equal to this. Now, they happen to be naming these guys room number, but you can make an argument at Objective-C where you could just name this guy RN. You don't have to have a really clean naming convention for your parameters because you described it here. It's probably doubly good to have them both be solid, but that's not the part I'm focusing on here. This is your parameter list for this constructor. But notice in Objective-C, the very first line is setting the value of the self variable. And we're setting it equal to the parent's constructor. Who is the parent of every object? We talked about it last time. Go ahead. Object class. Somewhere in the hierarchy, you will have somebody, will have the top level object that has a constructor called init, or in Java, it would be object, open close parentheses. And that guy will do whatever the bare bones version of initializing an object is. It's creating a memory address at the end of the day, and we are setting self equal to that memory address. That's what happens in the first line, always in Objective-C. We go over to Java and look at that same thing. That means we effectively have this is equal to new object. Now, they're telling us we can't change the value of this here. You know, they're saying the left-hand side of an assignment must be a variable. This is treated as something special in Java. They lock this down, but that's okay. But we can imagine that there's a kind of an invisible line there that's like this. At the very least, I am an object. Then what do? We do the stuff that differentiates us from a generic object. Here's what makes a fraction special. Make sense? This is what makes a fraction special. Go back to our Objective-C. This is what makes a FIS class special. This stuff. Okay, they're asking this question here to make sure that self actually got a value, so just kind of forget about that for a second. This is what makes it special. That FIS classes have name, room number, instructor, and students. Okay? Notice the very, 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 very last line. Return self. Return this. This is a pointer to this object that was just created. And this is a constructor. And constructors are always, always, always going to return a memory address. So we will capture in this variable the value of the internal value of this. Go ahead.
So would that kind of be like, so for example, if you were to do like fraction.display, is that really object.fraction.display in a way?
No, because objects don't have a display.
But
Fractions have a display.
would fractions, but since fractions is like a child of object, the base object type,
Yeah.
like is that like behind the scenes?
Here.
Would it be saying like object?
No, I can show it to you in code. So if I said this dot display, oh, actually he does. Oh no. He actually does have a display. You're right, but for the wrong reason.
Okay.
It's how they actually implemented the this keyword. I just said it's kind of a special implementation. The way I have this written here and the way I've explained it at this point is this is a pointer to this particular object. Actually, let me do it this way. If I say super.display, super is my parent, right? So super is my instance of object. Super does not have a display method.
Got it. Okay.
So that's one of the things that differentiated fractions from objects, is he got a super method. Okay? So the last line here always is return self in an Objective-C constructor. Objective-C makes you build this sandwich. Top piece of bread, bottom piece of bread, choose your filling. Make sense? The filling is what differentiates one sandwich from another sandwich. Java doesn't make you do this because it's always the same. But what I like about Objective-C is by doing this every single time, we remind ourselves of, oh, I am building a local pointer. I'm then differentiating myself. And then I'm ultimately returning a pointer to myself. That's what constructors do. Does that make sense? So there is an invisible thing here where we are giving this a value and we're returning that pointer to ourselves. But we don't have to write this in Java because Java's decided, hey, you would always write it that way, so we'll just do it for you behind the scenes. But understand, by the time you get to this first line, you already have a variable called this, which is a pointer to yourself. And when you hit this last line, our dying wish will be to return that pointer to yourself. We're not allowed to do that here because we don't have a return type. But that's okay because constructors are treated specially, and in Java, the return type is always a memory address. Does that make sense? This should be like the ultimate evidence that all programming is the same, because we just used a language that's been around since like the mid-70s to talk about how Java works. Does that make sense? And we could have used that same lesson for C#, that same lesson for, use the same lesson for Python. Magically, the self variable was just available. It just was there. All right. So let's quickly write the solution to your homework assignment. So ultimately here, what do I need to do? I'm taking in a string, and that string is in the format of numerator followed by a denominator with a slash in between. Okay. So what I'm going to do is, based on what we know right now, I'm going to have to build up two strings. Did I say you could use integer.parseInt or not? Oy. All right. Okay. 6 minutes. All right, go. So we're gonna build up our num string first. We'll start this guy off as the empty string. So what we're gonna do is we're gonna walk through f until we hit a front slash. Okay. So while let's just do a int pause. is equal to 0, while f.charat pause is not equal to the front slash. If I'm not currently looking at a front slash, I'll say numString is equal to numString concatenated with f.charat pause. And then I'll say pause is equal to pause plus 1. Or pause plus plus, if I don't think I've introduced that officially, but whatever. All right, so when we're done with this while loop, we will be sitting at, numString should have our string representation of our numerator. Then we're going to create, so now we want to get the denominator. So I'll go ahead and say pause is equal to pause plus 1. So this skips past the slash. Then I'll say string denom string, start that off as the empty string, and we'll say for int I is equal to, actually we can, well, I'll say it this way because it's going to be the most comfortable syntax for you. So I'll say, well, actually we'll just keep it as a while loop. While pause is less than f.length. Denom string is equal to denom string concatenated with f.charat pause. Pause is equal to pause plus 1. All right, so we'll skip past the slash, start a fresh string for a denom string, keep going as long as pause is less than the length of our string f, build up denom string each time with our next character, add 1 to it. By the time we get to here, we have 2 strings that need to become numbers, right? And they are string representations of decimal numbers. So I'm going to quickly write, I'll make it private. We'll talk about this next time. I'll be able to, so this guy's going to be private int string to int. This guy will take a string decimal number in as a parameter. We'll say int sum is equal to 0. We'll say int place is equal to 1. We're going to say string map is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we'll go ahead and do for int I is equal to des.length minus 1. Keep going as long as I is greater than or equal to 0. I is equal to I minus 1. Inside here, we'll say sum is equal to sum plus place times map dot index of des.charat I. All right, so this will get me the numeric version of that character. So a 0 will be the number 0, a 1 will be the number 1, a 2 will be the number 2, so on and so forth. I'll multiply that by place. I'll add it onto my sum. I'll say place is equal to place times 10, like that. So we're incrementing the place. In the end, we'll return sum. So then here I can say, this is up where I have my denom string. I'll say this dot numerator is equal to this dot string to int of numstring. This dot denominator is equal to this dot string to int of denomstring. And that should be it for that guy. So then out here we can say f4 is equal to that, and we'll say f4 dot display. Here, I'll just take these guys out for right now, and that should give us our 3/18. 1 minute spare. Go ahead.
String to int method, and then I realized you could have used the base to decimal method we wrote in program.
100%. It was that. I just wrote that method. Yeah. Yeah. I had 2 minutes. So I just well, and that's really a good example. Rather than going and grabbing a method we previously wrote, I just wrote it real quick. But it is base to decimal, passing in a base 10 number in. right? Okay. Now I'll post that code so you can follow it more quickly because, or more slowly, because I'm sure that, yeah. I'll show you a better way of writing that next time. But for homework for Tuesday, at least you see it's possible to write that pretty quickly, right? So for homework for Tuesday, we want to add the ability for addition to our fractions. So we should be able to add one fraction to another fraction and return the resulting fraction. That make sense? Okay. So I kind of want to give you a little bit more, but for Tuesday, make sure you understand the current code. I'm going to threaten a quiz based on what we talked about today. We talked about a lot of pretty deep stuff today. So possible quiz about what we talked about today. Make sure you understand this code and allow fractions to add themselves to other fractions, producing a new fraction as the result. Make sense? Good.
Is integer.parseInt not fair game for that?
Officially, no, but if that's the only thing you used, because have we done that? Didn't I say specifically you can't use that?
I thought you said we couldn't for like the binary to decimal, but since we like proved
I didn't say it for this one?
Yeah, you didn't say it.
All right, that's fine.
Okay, cool.
If you did everything, the main punchline of this one was to build, process through a string and get your two pieces. Go ahead.
So we should be able to add two fractions together no matter what the base of each one is?
Correct. Yeah. So I should be able to give you 3/8 and 21 27ths, and you should be able to add those two fractions together, giving me an accurate result. Not necessarily a reduced result. I wanted to give you reduction in the, for the assignment, but I actually want to talk about that as a time complexity problem. And so I would encourage you, if you want to play with it, feel free to try to do reduction, but you'll find that a program that you do, when you write reduction the way that's obvious, will actually take forever to run. It's a known time complexity problem, and that's why the Euclidean algorithm exists. So we're going to talk about that next time. So prepare for the quiz, do the homework assignment as is. I would say don't tackle reduction yet, because it's a very interesting problem because it causes a problem you wouldn't have expected in its own simplicity. All right, see everybody on Tuesday.
I have a quick question.